Great. So before I begin, I want to thank everyone for coming, sitting through this wonderful symposium. I'm honored to give this talk, and I'm also honoring Steve with some Aleacrine attention in this talk. I also need to preface this by saying this was a side project of mine. This was something that I did while I was working on my PhD in Connecticut, and found myself compelled to inventory the nearby state of Rhode Island. I grew up in Rhode Island. I'll give you a little more information on why I chose Rhode Island in a moment, but the title or subtitle, Biodiversity Hotspot, I had to add that after seeing all of these wonderful talks of all of these biodiversity hotspots. And I hope I can convince you that perhaps Rhode Island might be a biodiversity hotspot. You'll all be compelled to go there. There's a few reasons why this may be true, but I'm going to answer the question right now. Cut to the chase. No, it's not a biodiversity hotspot. I'm not insane. And I have very few landscape shots because there's not a whole lot to show you. So the question of why Rhode Island, well, I just have to answer that first off, is if I had chosen Connecticut instead, then I probably would have had a much harder time getting my dissertation done since I was living in Connecticut. The fact that I chose Rhode Island limited my collecting to just weekends and a few random events. So this was not a NSF-funded large-scale inventory, but rather what I could afford to do when I was visiting my mother. So I put the acknowledgments here because I consider myself more the project manager and running this, but it's the team who, maybe you didn't know you were part of the team of the Rhode Island Beetle Fauna project when I sent you material, but quite a few people helped with identifications who I'm indebted to greatly. A lot of people helped in various ways collecting. A number of students were shamelessly employed, rather not really employed, but used to help collect in Rhode Island. Curators who gave me access to collections and helped me out with borrowing material and various other aspects. And some money was provided, principally a great deal of support by the Rhode Island Natural History Survey, a group who have dedicated themselves to documenting the flora and fauna of this small and wonderful biodiversity hotspot. So also the Nature Conservancy and a few other places. My wife claims she kept me sane, but I think maybe the Beetles kept me sane. So first, beetle biodiversity, we know it's poorly documented. When I say relative to many other taxa, I don't mean insect taxa necessarily, although that's probably true. And mostly when we're talking about plants and vertebrates is the big other taxa that people tend to think of. I'm going to go through some counts, new state records, which I think are kind of dramatic and odd, and get into some numbers and some statistics that I hope you might be able to help me better understand after all of this, because we can, there's some just strange results here. Faunal turnover may be part of the answer. There's some other possible answers. I'm going to compare Rhode Island to other states and get into some species area curves. Charles Darwin had this quote to say, and I think this refers perhaps to extincting to Aleacrines: "The number of minute and obscurely colored beetles is exceedingly great. It is sufficient to disturb the composure of an entomologist's mind to look forward to the future dimensions of a complete catalog." So, Rhode Island. We have here, looking at all of New England, rather large area. So keep the proportion of Rhode Island in your mind to address New England, because I'll be talking about all of New England a little later. There's some offshore islands. Long Island is not part of New England, but note Connecticut and Massachusetts kind of sandwiching Rhode Island there. And oddly, if you ever noticed the National Geographic accents in North America map that came out a few issues back, Rhode Island has its own accent, different from Massachusetts and all these other places. It's a strange little state. So zooming in, looking at Rhode Island, we've got, it is the smallest state, and it actually has the longest name. A lot of people don't know this. The full name is Rhode Island and the Providence Plantations. Kind of odd too. But not a lot of topographic diversity. We have the highest point is 800 feet. It's mostly hardwood forest. There is some interesting small habitat regions that you can get some species that are quite rare or disjunct from other parts of its range. So there's these a variety of other places that are really worth checking out if you're going for beetles in Rhode Island. So when I arrived there in 1995 and began my PhD, I asked the local parapetologist at Yale, Bill Krinsky, so how many beetle species do you think are in Rhode Island? And he had, of course, been working with beetles in New England for quite a while and thought he might have a clue, but he didn't. And he suggested I check a paper that he knew about that very few coleopters know about. This was a checklist from 1904. But he also suggested that there was this 2-volume set coming out. And so when I got my hands on Down in Our Nets, Beetles of Northeastern North America, I went through it, combing out all of the Rhode Island records, and came up with 535 species. George Barrowclaw, ornithologist, said a prerequisite to making any decisions concerning the preservation of populations, species, or higher taxa is knowledge of their existence. And it's so funny how many people don't understand how poor our knowledge is of the existence of populations, species, etc. I'm speaking to the choir, of course, but this is something that many undergraduates complete their biology degree without really getting a good feel for. So going into the history, this is that checklist. The first edition, actually 1902, but this came out, and this was published by Charles Abbott Davis through the Rhode Island Entomological Society, which is no longer in existence, but a number of important contributors to early Rhode Island beetle work with Thomas Lincoln Casey listed at the bottom. Now Casey, he managed to contribute to Rhode Island beetle phonistics not by actually collecting Rhode Island beetles and providing checklists, but just by describing everything he saw as a new species. That huge peak that is due primarily to Casey's work. This is a graph taken from the Nomina insecta nearctica by Poulant and Tilley. And, well, one of the things about any biodiversity hotspot is you must have some endemic species. So we have here, thanks to the work of Casey, 61 beetle species that he named with type locality Rhode Island that have not been touched or seen since, leaving us with, of course, I've got endemic in quotes because they're certainly not endemic. What we have here is a testament to, even in a well-worked temperate region close to Cambridge, close to New York, and all of these great regions of northeastern biodiversity studies, lots and lots of work left to be done just to understand what we have in our backyard. So 103 of his species are found in Rhode Island that are good species. 61 are in this kind of limbo category of not having really been evaluated, and 64 have been synonymized already. And this is a Tilley, one of the ones, genus that he worked with. This list, it continues. I originally had 62, but the one at the very bottom, a Reichenbachia, has since been found outside of Rhode Island, I think thanks to Chris. So that's one off the list. There may be some others off this list too. It's a bit old. If you see any names that you know have been synonymized, you can grab me later. 44 of these 62 are Aleocarines, and 74 of these actually have the type locality of all of his species, including these, of the Casey farm. So where is the Casey farm? You can actually go visit this. If you, this is one reason why coleopters might want to come to Rhode Island. You can zoom in. You can see these hardwood forests. There is a hell lot of development in Rhode Island, but there's good collecting still. And if you go in, it's right on the shore there of Narragansett Bay, and this is his family property. You can visit. It's well maintained by Historic Society, and they actually run a summer program there with an organic farm, and they have a graveyard. You can look at the family history, etc. And maybe, with permission, collect a few topotypes. So, knowing that the 535 species from Downey and Arnett was a bit small, I went through historical collections. Roger Williams Park Museum of Natural History, the LP body, had a huge collection. This is by Martin Bowe. I don't really know who Martin Bowe was, but he collected extensively at turn of the century and formed the bulk of Yale's beetle collection with that accession. University of Rhode Island had a collection. A lot of these are fairly good sources. Then these two publications, the Davis publication, after checking, had a 908 species. And once I went through the Leng catalog, 1920, with 215 species. So Leng and others had missed that Davis work earlier. So pulling these all together and getting rid of the duplicates, we have 1,716 species, which is a kind of a reasonable starting point and something that you might expect to find in a place like that. So my weekend collecting turned it up 841 species, which is Martin Bowe did better than me at the turn of the century. But and I haven't completely closed the door on the project, so there's still some species trickling in. All sources combined, we've got a list at 2,255 species for this very small state. New state records. This is where I started to think something was really strange, because of the 841 species that I collected, 356 of them were unreported from the state. And could you imagine a botanist or a grad student in botany going to any state in the United States and collecting 841 plant species, the very first ones that you come across, and 356 of them are unreported from the state? Never. That group is done. This is still far from done. In many states, I think we have a huge amount of basic phenistic work to do, and we all know this. 701 new state records altogether, which combine with a lot of those historic records in the museums that just were never published. Now you may think, well, Rhode Island's a very small place. If I just decided to look for new backyard records, well, nothing would be published from your backyard, so everything would be a new record, right? If it's a small enough area, everything's going to be new. But let's look at New England. New England's a bit larger. We've got 121 new records from my collecting in New England, which is a fairly large area, and all sources together 250. So this came out in publication, volume 3 of the Rhode Island Natural History Survey Biota of Rhode Island series. They have already done the vertebrates and the plants, and the plants top out at about 1,980 species. I'm going to go through some of the species of interest. You've all heard this story of Nicarchus americanus, the endangered species, with its widespread historical distribution and its current distribution limited to only the western periphery and some eastern islands and the breeding colony in Providence. So, and just to go back, that population on Block Island down there is where it was found and survives today in the east. So a few others. This is, I think, a story that's not as well known. This is a hysterid that we picked up on Block Island, and Michael Caterino's work with this genus, now subgenus, indicated that this species hadn't been seen since the early 1950s, and he suggested it was in need of study from a conservation perspective. Don't really know the biology, but we found it on West Beach on Block Island. A botanist friend of mine actually found it. We've been back to that site many times and haven't been able to find it, but presumably it's there and just we need to put in more effort to get it. But it's and perhaps it's certainly not as easy to trap and survey as the American burying beetle. This is a new state record, a beautiful cerambycid. My daughter found this when we were out hiking on a family trip, and something that the Victorian naturalists would have grabbed in a second if they had seen it. But it I'm suspecting, because these are wood-boring, and the forests 100 years ago were virtually eliminated from most of New England, that may explain why it hadn't been picked up before. Here we have a Snebrionid, a fairly large insect. This is a centimeter total, and it's although they are a bit cryptic when you break open brachyfungi like Ganoderma, any collector would eventually spot them, and these are again unrecorded from the early publications. So a bit shocking to me that these rather dramatic insects had escaped detection, but again, wood-associated indirectly. Here we have another new state record, a flea beetle that feeds on a sea rocket, which is a back beach growing cruciferous thing. It's a native species that now I think is becoming rare on the mainland. On the mainland we're finding a European congener that perhaps is out competing this native species. So this is something that we've found in abundance on Block Island. Once again, it seems the island is acting as some kind of refuge or buffer to change. One of my entomology students picked up the first New England record of this animal, a beautiful Mediterranean Ontophagus. And then an Aleocrine in honor of Steve. Here we have the first, I think this would be the first record for New England for this European species. It was reported recently from Quebec, not from. So getting into more of the statistics and the strange results. Species area relationships, one of the most studied patterns in ecology. It's well known to everybody. The larger area you consider, the more species you end up with, sort of a general pattern. But they've used this pattern to examine a number of different aspects. I'm not going to go into them, but probably the most famous is island biogeography, McCarthy and Wilson. Here's a simple example using West Indian butterflies. As you, on a log scale typically, the area on the x-axis and number of species on the y, you get a nice positive relationship. Now, Loma Limo in 2000 did a review of species area papers and noticed that there was a lot of variation and that it wasn't a simple pattern that was easily predicted. And one of the things he thought was happening is that on very large scales, it's being driven more by speciation than at the intermediate levels where you're getting immigration and extinction. And at the very smallest levels, there's stochastic effects that are eliminating some of the pattern you might expect. So this is what he called the small island effect. And here's an example from his paper showing birds in the Malaysian fall region. You get the positive relationship that you'd expect, but at the very smallest land areas, it's a bit of a scatter, and you're not seeing that pattern. Whether that's relevant to Rhode Island or not, there's something that happens when you do consider very small areas, that it breaks this pattern, or there's something that goes strange. So this is a list, a table of sorted by size in square kilometers, and I don't have California on here yet, but I'd like to get that on there pretty soon. With all of North America north of Mexico at the top, 18 million square kilometers with 25,000 beetle species from Marskine Ivy's 2003 paper summarizing what's known for North America. Canada and Alaska at 7,400, northeastern North America at a similar amount, and it seems California is coming in at that similar 7,000, but it'll probably go much higher, of course. Going down this list, we can look at Alaska, my new home, with 1,205 species recorded of an enormous area. Now, remember, there's the latitudinal species gradient that has to come into play as well. Rhode Island, with only 2,707 square kilometers, 2,255 species. So these are the numbers for beetles for North America. We have North America at the very top, then we have Canada and northeastern North America at the 7,000, and California would fall in right about there. A variety of other states, with Alaska below the line, Florida well above the line, Rhode Island well above the line, Prince Edward Island below, Nantucket and Block Island at the very bottom. If we get rid of Rhode Island and Prince Edward Island and we look at latitude, so we have latitude on the x-axis, so we'd the equator down at 0, and my new very cold and north home at the 65 degrees north at the top here, with species, actually I've lost the axis descriptor on the y, but this is species per kilometer squared. So I've tried to standardize it. So just take the number of square kilometers and make a ratio. Florida coming out, I mean, it's the pattern you'd expect. the closer you are to the equator, the more species per square kilometer you have. And as you go north, the fewer. We add Prince Edward Island into this, and our slope drops a little because it's way above the line. And then we add Rhode Island. Rhode Island, notice the y-axis, we are now close to 1 species per kilometer squared with Rhode Island. It's a major outlier for some reason. All the other regions, so this is a biodiversity hotspot. See what I'm talking about? So is this count too high? Well, one thing to consider, and this problem of defining lyotids or pornography comes to mind when you use the word fauna. I mean, what does the word fauna really mean when we say this word? I thought I knew until I really started doing this work, because I'm pulling together records stretching over a 100-year time span. And we've had this enormous ecological change in the area with forests returning. So does this number represent the number of beetles that have been shown to currently breed in Rhode Island? Well, that's what most people think when they hear fauna. They think of it as a snapshot in time. That's what's there. But in fact, what we're really doing is we're documenting the number of beetle species that have been collected within that region. And those are subtly different because, of course, the fauna changes. It's a dynamic thing. And you're trying to nail down a dynamic thing with a single number. So looking at the historic versus modern records, we look at just the modern records, and my work plus another collector in the state, Reginald Webster, we come up with 981 species collected in the last 50 years. 41% of those are new state records. That leaves 1,273 beetle species that have not been collected in the last 50 years. That's a large chunk of the fauna that hasn't been seen. Now, granted, these are weekend collecting trips. This is not an intense survey. If we had lots of effort, I'm sure we'd get a huge portion of these historically documented species, but we don't know how many. We don't know how many are gone. We do know the ecosystems have turned over. Sometimes people who don't know much about history, they see all these stone walls in New England in the forest and wonder, why did they build stone walls in the forest? And the answer, of course, is that was ranch land. That was grazing pasture when those walls were built, and all these forests have come up since. So one way to look at this as well is to compare the mainland, which is really reforested, to Block Island, which has stayed virtually the same. 48% of the mainland records are new, but only 30% of Block Island records are new. So Block Island doesn't seem to have as many new records as the mainland. This suggests that there's been more change on the mainland. But remember, we're working well below 100% of the fauna, so there's lots of other factors involved. If there's been a widespread replacement, the count could be too high. We might not have over 2,000 beetle species breeding in Rhode Island right now. Looking at some other regions, these smaller regions, and these are my last few slides here, so I know we can get off to dinner. Oddly enough, Alaska and Northwest Territories have, if we're looking at just the region Alaska plus Canada, so now we're just sticking to the north, Alaska represents almost 16% of the area and has almost 16% of the total species. Northwest Territory, similar numbers, 14% and 14%. So on this line of unity, we've got species in the region versus species total ratio on the x-axis, and we have the area versus area total on the y. Alaska and Northwest Territories are on the line. They're the only ones on the line. Everything else is way off the line, with Ontario being this major outlier, having 52% of the total species and only 12% of the area. This is obviously collecting artifact. But it's a lot. So the current beetle fauna may not include 2,255 species. This total may include species from Connecticut and Massachusetts that rarely breed in Rhode Island. Just like if you started sampling things in your backyard, and as Dave Wagner did with Microlepidoptera, ended up with 1,000 species of microleps at his blacklight in his backyard, they're not all breeding in his yard. How many of these 1,200 species not seen in 50 years are still present? Don't know. Conversely, the Rhode Island count may be near the total, but all the other states of North America may be far below. Oh, and that's it.